All right, everybody, welcome back to Off the Grid on the Record, the podcast where we dive deep into the innovators building what's next in clean tech, sustainable infrastructure, and energy independence. Today, I'm joined by Samuel Bendek, co-founder and CEO of Elastic Energy, a clean tech startup that's quite literally growing the future of energy storage. They've patented a battery system made from natural tree sap. That's right, an organic alternative that's safe, recyclable, and long lasting. We're going to talk about how this innovation could rewrite the future of renewables, how they're navigating scale, and what it means to build climate tech that's not just sustainable, but regenerative. Samuel, thank you so much for being here with us. How are you doing today?
Hey, Charles, thank you. Yes, I'm thank you for the opportunity and being part of this community that will have the goal of making the world better. So yes, thanks again for the opportunity.
Of course, we're happy to have you here. And I've got to ask, energy storage using tree sap. That's wild. So, how did the idea first come about?
Well, yes, it actually is. I would say it's quite a story there. When I was 15 years old, I started working in a soccer ball factory in my native Colombia. My job was literally bouncing the soccer ball. So like my job was to test these soccer balls. Um, so when I was there and when I was testing these soccer balls, I said like, what if we use the same elastic concept to store energy? So soccer ball is made out of tree sap in the inside. It's made of a natural rubber, but it's basically tree sap in a specific in a specific like form. We take that material and we say like, how can we take that and make a battery? That was the initial idea. We had to work a lot. We have to build a team and eventually get some funding to get it to keep going. Yeah, it came out of a soccer ball factory.
That's amazing. And then just for everybody listening that's not maybe as technical or even myself with some of these things, can you explain in simple terms how your battery technology works and maybe how it compares to lithium ion or tradition or maybe more traditional just like battery chemistries?
Yes, of course. I don't know if, well, everyone has seen the old grandfather clock that you have to wind it with your own hand and then it's gonna stay there. And when the battery, like I quote batteries, run out, you have to like wind it again. How they work is basically they have a spring inside and you twist it with your hand and you wind it. We have also seen this concept in toys, maybe the little car that you wind and then starts going on. We use that same like the same elastic concept and we take it to an industrial application. So what we do is that with this tree sap, we make an elastic band. That elastic band stores energy when stretched and then releases that energy. So we took the elastic band, we put it in our machine, and when the battery is charging with a motor, we elongate this elastic band from 20 to over 100 meters. And when energy is needed, the process is reversed, the elastic band recovers, while moving a generator, converting elastic potential energy into electricity. So,
Wow.
how it compares to a lithium ion battery? Basically, the lithium ion batteries have three main problems. They are very bad for the environment. Uh, they don't last too much. I don't know if you have seen in your phone, and every like 3 to 4 years, you have to like throw your phone because the battery doesn't last more than an hour. That happens in
Exactly.
also at an industrial scale. Also, they cost a lot. Batteries cost a lot. For example, EV vehicles, the battery is 60% of the whole cost. So as you can see, they're not um, cheap. So what we did
Exactly.
is that this battery allows the customer to have a technology that lasts 30 years, like the old grandfather clock lasts 30 years. It's fully sustainable. We only use natural materials. We don't need to kill the trees to make this extraction. And we project a 40% reduction cost in total ownership cost at the end of the lifetime of the use of the technology.
That's amazing. No, and you emphasize that your systems are, mineral free, fire safe, recyclable, long lasting. Like, and you're not even killing the trees to get these out. So, I think the obvious question is, what were the biggest challenges in actually engineering that?
Oh my god. I could go on and on and on. First of all,
Well,
I
give
have
us
to say very clear.
a simple answer then.
Yeah, but first, before I answer, I have to be very clear in saying that I didn't solve all of this alone. We had a team. We have right now a team of engineers, very smart, that we work together, and together we were able to solve this challenge. But if I have to summarize, what is the biggest challenge that we have to fight with, is that that elastic band that I'm talking right now is not the ones that you have that girls used to for her
For
hair.
the hair.
No, it's not that one little. The ones that we use, it actually needs and it requires 10 tons of force to be able to elongate it. So
Wow.
10 tons of force is like 3 to 4 cyber trucks. So
Exactly.
it's a lot of force, a lot of strength, and most of the prototypes and technologies that we do in the lab, they imploded. Like they just don't work, didn't work.
Hmm.
So we had I put a lot of R&D and a lot of funding in solving that problem. But right now we actually were able to solve that with this team of engineers.
That's fantastic. And what types of use cases are, I guess, best suited for this technology today? Is it residential, commercial, industrial, maybe like grid scale?
Yeah, great question. So initially, the technology will be used for more industrial scenarios. We're talking about high peak discharge. What does that mean? Is like in applications that you need to discharge the battery in a matter of minutes. You cannot do this with a lithium battery. They explode. They cannot. You cannot discharge the battery too fast because they start burning. So our technology allows that. The same that you can take a spring and just deploy it in a matter of seconds, you can take this battery and discharge it in a matter of seconds. You can imagine this application for hydraulic presses for metal. You can imagine also seeing this also in um, there are a lot of like applications in the factories. We initially want to work with them and then goes to other type of markets. Could be the residential, that is used for renewables energy. Basically, they charge the battery in the day, so they have energy with solars, and in the night when there is not much sun, they use the battery.
Hmm. That's fantastic. And I love the idea, but another thing that I always like to think about is a lot of hardware setups or startups, sorry, hit walls with things like regulation. And I think that's usually like the biggest thing. So, what's been your experience navigating standards and compliance for a product that's, I want to say new, but innovative?
Well, I do have to say that we had help here because a family member works in exactly what you described as regulating with battery storage here in the United
Hmm.
States. So he guided us a little bit through the process. We're still doing that process. I will say that it's a little expensive. It's very expensive,
Of
and
course.
more in energy storage. Energy is a critical industry, so it's very expensive and a lot of effort. But it's basically documenting the technology and proof that it's not gonna explode. So
Yes.
that's what we have been doing, and that's what we have put a lot of our effort.
That's fantastic. And I think the speed of regulations is kind of what slows people down. That's what we hear a lot on the podcast. In your opinion, I guess, have energy storage regulations kept up with the speed of innovation, or are they still written for, last decade's batteries?
I will have to say that is very slow. The process is super slow.
Hmm.
For us, it has not dragged us down because we started very early, and we also keep developing the technology. We're still working towards that MVP. So while we do that, we're also getting the regulations approved. But what I could say is that if you wait to get the MVP ready and then you go and start without any like previous work to the regulations, oof, that's gonna be a tough journey to travel. It's gonna be
Exactly.
long. So we had
That's amazing. So you guys
to
have
even like
navigated it
work
in a very
before
good
we go
way.
to that MVP. Sorry, yeah. Go ahead, Jared.
No, I'm just saying that you guys have really navigated it in a very good way. And I think that's a very interesting way to look at things, right? Like you really have to be passionate about what it is before you actually bring it in to get regulated. Because a lot of people will, submit something, see if it, comes back positive, and then they'll get to work. But you guys did it completely opposite, which is kind of unheard of, actually. So I really like it and I really appreciate it. And I think the main reason of that is that there's shifting values around energy sovereignty and like the clean energy future. So I think that elastic tech like really shifts the conversation away from like mining, for all of, even like battery components, but you guys change it towards biology. What does energy independence kind of mean in that context?
Well, here's the thing. I have to go back forward for um, saying that my father used to said to us. We're here to make the world better.
Hmm.
The main goal for why we are here, and at least for me, is that when you leave this planet, you can say like, okay, I did a mark. I did something that leaves the world better.
Hmm.
Um, and with that mentality, we actually had the same problem that you just described. Why we have to keep mining to solve the renewable energy problem? Why just look something that we can actually build and plant trees?
Hmm.
So
Exactly.
that's the goal, to make the world better. And I think with this solution, we can solve the renewable energy intermittency problem with this kind of renewable batteries, while you don't mine, you build your plant, you grow the planet, if you want to say so.
Exactly. And is it safe to call it a battery?
I will say it's an energy storage system. Usually batteries are referred to chemical technologies.
Yes.
Our will be an energy storage system. But also, if you go to if you go to, let's say, a normal like crowd that are in a lot of markets, not just experts in energy storage, and you
Hmm.
said that you're not a battery, they will be like, what? No, but you're you are a battery. But you are. And you say like, yeah, you know what, I'm a battery. But like, the actually term is energy storage
The
system.
technical term.
Yes, that's the thing.
Fair enough. Okay. Well, then, do you see your energy storage systems enabling more decentralized microgrids or like rural electrification projects?
Totally, totally. I say the industrial application is because the start, like that's where we're gonna start. We're gonna start with this one, because we can start with a couple of them, and we have some letter of intent there. But once we actually manufacture this at a scale, and we can get to the necessary price to beat lithium-ion batteries, or to compete with lithium-ion batteries, this battery is gonna have to be used for, and we love to be that we use it for grid scale, microgrids. So
Hmm.
basically, the application there is that they put a farm of solar panels, a lot of solar panels for us, something that is not connected directly to the grid, and once there's an excess of energy, they use that to power the batteries, to charge the batteries, and in the night, when there's not much sun, they use the batteries to power the homes. I
Hmm.
totally see that technology being there, because it lasts 30 years. At a scale, is cheaper and is fully sustainable. I really think that's gonna be one of our main applications in the near future.
That's fantastic. And I mean, even to date, you guys have hit some amazing early milestones. And I guess we kind of touched on it a little bit earlier, but I think more technically, what have been the toughest growing pains in getting from, the lab to the actual market?
Could you repeat that question, please?
Sure, sure. Like you've hit some amazing milestones. What have been the toughest pains or roadblocks or, speed bumps in getting from, your R&D in the lab and, actually building the product to bringing it to the market and seeing how the market responds to it?
Okay, so, and I think this problem happens to a lot of R&D companies. The biggest problem is that you're selling something that is not there. Basically,
Exactly.
it's not like you have a product and you said like, okay, my product makes X, Y, and Z. Why do you want to buy it? No, you you don't know those X, Y, and Z. You have in a spreadsheet, in a calculator, in a simulator, but you don't know if you're gonna be able to make it or how it's gonna look. That has been
Exactly.
tough for us. Right now, we have a lot of more information on what the battery actually does in the real world. 6 months ago, it was tough. It was very, very tough. Go to an investor and said like, because they're always gonna ask you, like, hey, does your battery do? How do I compare it precisely to a lithium-ion battery?
Mm-hmm.
Being in the R&D, still putting the nuts and the screws, is like, okay, I think this is what I'm gonna make in the near future, but that is very difficult to solve. How we did it, it's a lot of math. We had to work with with professors. We had to work with people that were experts in the industry, in also in chemical materials and elastic materials, so that we can be certain that what we have in our calculation and projections could be something that we can go to an investor and say like, okay, give us this amount of funding, and with that we will be able to deliver X, Y, and Z.
Mm-hmm.
But it's not this year. That was tough.
Exactly. I believe it. And like you're saying, like you're now in conversations with investors and utilities and obviously trying to get the brand scaled. But how do you stay true to the mission of maybe not selling out to anyone and really keeping things consistent and still affordable when it does hit the market?
That's a great question. I would say that we have been fortunate that the investors and the people that has helped us to build this has the same mentality and same values.
Mm-hmm.
They have gone along with the main purpose of the company, the why of the company. But as you said, probably in the future there's gonna be a big offer for maybe someone that doesn't align so well with the values of the company. We will say
Exactly.
no. We will say no
Fair
to that
enough.
big offer. We will say no to that big offer. We have values. The founders have very, very strong values, and the team has very, very strong values with making the world better, living the world better that it was given to us, and we're gonna stick with that.
That's amazing. And I think this might be a bit of an early question, but it'd be great to kind of get the idea of where you guys are coming in from because you're in a unique position where your product requires, both scientific credibility and public imagination because people don't know what's going on in there. People don't know what this is or how the technology works. So, how are you approaching the marketing? How are you approaching getting it out there, getting the information and the news in front of people?
Okay, yes, I'm more the technical guy, if I wanna call it. I co-founded this with actually my sister. She is great at selling to people, talking to people, really touching those feelings. I'm more like lab guys. I'll at least say what I have learned from her, but everything that I do and I say is based on what she did.
You got it.
What we like to do a lot is to compare to things that people can relate to.
Hmm.
So, for example, the old grandfather clock, people can relate to that, or the old toy that you can wind with your hand, people can relate to that. Maybe another one will be well, soccer balls, but that's actually part of the story. But let me think about what else have been said. Well, once
So
you
I
go
guess it
to
is mainly just through your network, right? Like you're not necessarily going out and, running all these ads, sending out email campaigns. You're not necessarily putting it in front of people yet, but you're getting the idea out there that this is something that's in the works. This is something that is in development and can eventually one day really bring a huge, like a huge impact to the market. So is that kind of more so
yes,
aligned?
that's exactly what we have been doing. We actually have been very fortunate that the news and the have come to us because
Hmm.
they they like what we're doing and the mission of what we're doing. So we have not make any, if you want to call it like that, investment in marketing like campaigns. We have
Hmm.
used most of our funds in R&D and actually build this technology for the world. And with that, the getting out there has been like a second indirect goal if you want to go like that.
Mm-hmm. That makes sense. And I think the approach is interesting because you guys are very like very well run, and I feel like you always mention you have a team, but are you guys seeing more traction selling or, potentially selling? I think is the conversation now we can have is potentially selling to B2B, so selling to business owners, or are you selling directly to like customers? Like, can this be used in homes? Can this be used? I mean, obviously you've mentioned like industrial scale, but can it be used in on smaller scales to power, I don't know, say a sauna, say, something a little bit more technical that you don't necessarily want to be able to, run a cable to, you know what I mean? Something on those along
Yeah.
those lines.
So yes, here's the process with R&D and taking something to the market. Like the first prototype is huge. Usually it's like huge, and it costs a lot. That was the first one that we did. Now we're getting to a relatively small size, but it's not suitable right now for commercial. Sorry, um, you said it,
Residential.
residential. Thank you, residential use right now. So our technology right now is at a size and at a cost that is more suitable to B2B business,
Mm-hmm.
industrial use. But totally, it has all the potential. Our manufacturing process right now is it's not the best. I mean, in terms of resources, we don't have the best resources. Once we get to that, once we can, I will say, make this battery at least 4 to 5 times smaller, um, with more R&D, and we will be able to enter this
Mm-hmm.
residential market.
That's fantastic. But that's I love the idea. And so maybe if you could just share with us, if someone hears this podcast or hears about, what you're doing, and wants to either support you or to partner up with you, where do you want them to go?
Yeah, elasticenergy.co. That's our main website. You can see all what we have done, all of the team that is there, and you can actually see the battery. Mm, if, that will be very helpful. Thank you, Jarek, for the reminder of that. I really think that this community has the same goal that we had of, again, making this world better than it was given to us. And we should all work together. We should all um, talk, um, and share so that we can actually deliver that final goal.
Exactly. No, that's amazing. And just on like a ending note, what advice would you give to other clean tech founders trying to bring a new bold idea to the market, trying to do something unheard of, but they have that drive, they have what they think they need? What kind of advice would you give to, kind of push or slightly influence those people?
Well, before I said that, I would like to say a story here is that there, for some reason, when I've been building this, when I built this in my garage, when I was 15 years old, a lot of people came to me and they didn't believe it. A lot of people were like, "No, you're not doing that. This is not possible. Um, you need a PhD. You need 20 years more experience. You're not gonna be able to do it." And what I will say there is that, in my perspective, they are saying that because they don't believe in them. They don't believe that they will be able to
Mm-hmm.
do it. But I know that they will. What I'm trying to say here is that just try it. Like, it looks complicated. It looks from the outside, it looks like it is super impossible. That only 1 in a million or in a billion people can actually make a deep tech startup. No, no, that's not true. Anyone can do it. Anyone. It's just try it. Try it. Solve one by one small problem by one, and eventually you will have a complex machine that you and your team build it together. Um, because you need a team. You're not gonna do this. What I will say is that you're not gonna change the world alone. Um, there's a saying in my university. They used to say this a lot at UMBC. It says it takes a village to change anything. It takes a village, uh, and that's right. So try it, make your team, and try it because you will do it. You have what it takes to leave your mark in the world.
That's fantastic. And I think that's a fantastic way to wrap it up. So I really want to say thank you to Samuel Bendek for joining us and opening up about the future of nature powered energy. Thank you guys for joining Off the Grid on the Record. You can learn more at elasticenergy.co, and I highly recommend checking out their visuals to really understand how this works. I'm sure we can explain it as best as we could, and we could have the best explainers here, but until you really see it, I think you're going to be very, very curious on how that all works. So, again, elasticenergy.co, take a look. And if you've enjoyed this conversation, be sure to subscribe on Spotify, YouTube, or Apple Podcasts, wherever you get your podcasts. And if you know someone building a cleaner future, send this their way. So until next time, keep it intentional, keep it sustainable, and we'll see you off the grid. Take care, everybody, and thank you so much, Samuel, one more time.
Thank you again for the opportunity.
Of course. All right, take care, everybody. We'll see you next week.